Hello, everyone. My name is Ian Curtis. I lead the Zscaler SecOps sales engineering team covering the Americas. And in this video, I'm going to break down a couple of AI-powered attacks, as well as some things that you can do to better defend yourself against them. Let's get started. So there are two tiers of AI-powered attacks that you should be aware of before you go out and craft any new defenses for them. And the first one is going to be used by your lone wolf. This is not your nation-state sponsored threat actor. These aren't people with lots of tools and technology and money, but rather this could just be somebody who goes out, downloads Kali, realizes, hey, I have a chatbot that's going to walk me through how to carry out my attack. So the underlying technology here are things like large language models. An LLM can be very powerful for interpreting text, generating new text in the form of instructions or code or commands. Also, we have things like convolutionary neural networks. This can interpret what's happening on a screen or in a room if it's over a camera and really understand that spatial data really well. Next, we have things like automated speech recognition. Now, this is great for generating new speech or interpreting existing speech. Really, really good for social engineering. All of these technologies can come together in the form of a single chatbot that the attacker interacts with. Now, I call out a chatbot because it's very easy to use and everybody tends to understand chatbots. But if I don't know how to use a tool, or I don't know how to pivot between tools, or I haven't memorized many of the commands for these tools, a simple chatbot can make me much more effective and faster in the attacks that I carry out. In addition to chatbots, we have things like, Geeknik and Havoc and Hexstrike. These are tools that have been enhanced by AI that allow the attacker to be a lot more effective as well. So these things will craft new payloads for them, allow them to fingerprint the environment and move laterally, and even steal data without them really knowing much about what they're doing. So that's tier one. Now, what about the next stage and evolution of AI-powered attacks? So our tier 2 AI-powered attack is going to leverage an agentic approach. This means that we're going to string together multiple components into a pipeline to automate a lot of the functions of the attack and run them simultaneously. Now, in this case, the attacker is going to interact with what we would call the brain. Now, the brain is oftentimes a commodity-based tool. So this could be a ChatGPT or a Claude. Now, a lot of these tools are designed to have safeguards in place so they can't carry out a typical attack very easily. They're supposed to stop the end user from doing that. But in this case, the user is not having Claude interact directly with the target. Instead, they're using an MCP server. So this is a model context protocol server that does a few different things for us. First of all, these tools translate from one AI tool to external tools and maintain the state of every connection that it makes. So in this case, it serves as a layer of obfuscation between the brain, so it doesn't know what's going on, and the actual target at the bottom. It also allows us to run many operations simultaneously. So what it's acting on and what it's asking to perform actions for it are these common, everyday, run-of-the-mill pen testing tools. So this might be like an Nmap or a NetScan or a Metasploit, right? Or an Aircrack, NG, something like that. Now, these tools are ultimately performing their functions against these common targets. These could be companies, these could be government agencies, right? But regardless of what they are, these entities likely have not seen this level of sophistication or complexity before. These attacks are going to be largely automated. They're going to move very, very fast, and they're going to have multiple stages of the attack running all at once. So it's going to be very hard to string together the different phases of the attack and associate it with one attacker. They could also be coming from multiple different sources, which makes it even harder to do. So in this case, the first attack we've seen of like this was detected by Anthropic, and more than 80% of what was detected was actually automated. So that means what was taking place between this tool and this target was not coming back to the attacker to say, do you want me to validate this command? Do you want me to change or decide what happens next? It was just automatically running the entire attack mostly alone, and that's pretty scary. This means that our dwell time needs to decrease dramatically, or our detection latency needs to decrease dramatically as their dwell time decreases. And finally, our ability to detect cannot rely exclusively on the tools that we've had in place for years. We need to think of a new approach. Okay, so the first thing we need to be able to do if we want to defend against AI-powered attacks is to better detect them. So this is a little bit different than it used to be in the old world, where we relied a lot on signature or static-based detections to trigger alerts for us. But we found that tools like Havoc or Geeknik or Hexstrike can easily bypass these detections because they'll fingerprint what they're doing and craft new payloads in real time to get right through them. And the same is true for some, but not all, of our heuristics-based detections as well. They can fingerprint what will trigger an alert and craft a new payload to bypass that too. And so another tool we have in the toolbox that we have to take very seriously is deception. So deception resurfaces as an essential detection mechanism. And the reason for this is because, one, it doesn't rely on any rules to trigger an alert and watch what the attacker's doing. There is no higher fidelity threat intelligence than watching the attacker live. So we gather that threat data, and even if the phases of the attack are being launched simultaneously, they're automatically stringed together and associated to a single attacker. So let's look at what this attack might look like. So the attacker themselves usually start by looking for public-facing assets. So once they find an asset that's highly vulnerable, they can land on a system and that gets them inside the network. But once inside, that doesn't give them the access they need to persist inside of the environment, so then they'll move on to escalating privileges. And they'll do this by looking to an Active Directory account, maybe an account that's vulnerable to something like Kerberoasting. And once they gain access to admin privileges, they have the keys to the castle, and they can land on a higher internal system, move laterally, and gain access to things like PCI data or HIPAA data or other valuable information that they can steal, encrypt, and perform some form of actions on objectives. So what deception allows us to do is to place decoys and landmines throughout the environment that look like real systems that are highly vulnerable to an attack. Now, these systems shouldn't be easily discoverable by your employees because they're not using FQDNs or URLs that are associated with systems they would be using. So once this attacker gains access to a vulnerable system, they think they're on a real system. But really what they're on is our decoy that's being watched by an administrator live. So this engineer is watching what they're doing, and maybe in this case, they also look for credentials that are fake or decoy credentials as well. Once they get access to those fake systems, they start moving around on internal fake systems. Now, it seems like this is a massive infrastructure that we have to deploy throughout our environment. However, much of this is cloud-based or SaaS-based decoys that I can deploy by the thousands, in some cases as little as an hour. By the time this attacker goes to perform actions on objectives, we've already been able to contain them or pivot to a managed detection and response service or craft a managed threat hunting service that will take advantage of this unique data as well. So in the world of agentic-based attacks, deception reemerges as a critical tool that we have for detecting them. And it's not just because agents run quickly, but rather because they run multiple phases in parallel and because they can bypass rules-based detections we've had in place for years. Obviously, once we detect, we need to be able to better respond and to adjust our security program as quickly as possible. I'll cover those things in follow-on videos, but if you have any questions here, leave a comment or reach out to your local team. Thanks for viewing.